Morning, students. Myself, Vijay Shankar from Electronics and Communication Engineering Department, Chevrolet Engineering College. Today, we are going to discuss about the inverse Fourier transform and their examples. We already discussed about the Fourier transformation and properties of the Fourier transformation and some of the examples of the Fourier transformations. And now, you go for the discuss about the inverse Fourier transformation and their examples. So we already know the inverse Fourier transform equation x of t is equal to 1 by 2 pi x of t is equal to 1 by 2 pi the integral minus infinite to infinite. See, the x of t is a Fourier transformation of x of omega, and inverse Fourier transformation x of omega inverse Fourier transformation of x of t means now the output function is the x of t output function. X of t is equal to 1 by 2 pi integral minus infinite to infinite x of omega e power, actually here it is a minus for the Fourier transformation. Now it is a positive exponential e power j omega t omega e power j omega t d omega. Now, the examples of the Fourier transformation, mostly you are not using the formula by using the partial fraction expansion method or by using convolution method. The indirect method we are using to find out or to solve the problems in the inverse Fourier transformation. Inverse Fourier transformation. Okay, my dear students. So see the one example here, the inverse Fourier transformation. First one, x of omega is equal to 2j omega plus 1 by j omega plus 2 whole square by partial fraction expansion method. And another example they are asking here, the x of omega is equal to 1 by a plus j omega whole square by using convolution. This is the indirect method, the partial fraction method and the convolution method. So the partial fraction method, the first one you can see the x of omega is equal to, you can write as, so I will explain here. So the example is given x of omega is equal to 2j omega plus 1 by, once again I will see that, two j omega plus 1 by j omega plus 2 whole square. J omega plus 2 whole square. Find inverse Fourier transformation. Okay, 2j omega plus 1 by j omega plus 2 whole square by using partial fraction expansion method. By using the partial fraction expansion method. 2j omega plus 1 by 2j omega plus 1 by j omega plus 2 whole square. Now to see the partial fraction expansion method, that I am taking here the 2j omega plus 1 by j omega plus 2 whole square. So by using the partial fraction method, see, using partial fraction expansion method. Okay, my dear friends. Now here the denominator is a plus b whole square formula. So the a by j omega plus 2 plus b by j omega plus 2 whole square. If suppose it is a 3 means j plus j omega plus 2 plus b by j omega plus 2 whole square, and the other one is j omega plus 2 whole cube is equal to. Okay. Now take the LCM is j omega plus 2 whole square, as here the a into j omega plus 2 plus b, and here is equal to the 2 j omega plus 1 by j omega whole square. So the equation now it becomes of 2 j omega plus 1 is equal to a into j omega plus 2 plus b. Okay, now I can find the a value and the b value by comparing the j omega coefficients, left hand side and the right hand side, or otherwise to find the b, compare the constant values, the left hand side and the right hand side, or you can substitute the j omega is equal to minus 2, or otherwise j omega is equal to minus 2. Here the 2 into minus 2 is a minus 4 plus 1, so minus 4 plus 1 means minus 3. Minus 3 is a b value. Okay, my dear students. Then after you can find the a. Otherwise, you can compare the values of j omega and here the j omega coefficients. 2 is equal to a. So we got the a value. Understood, my dear students. Now, another one is compare the constants. What is the constants here? 1 is equal to a, 2a plus b is also constant, b. What is the a value here? The 2. 1 is equal to 2 into 2 plus b. Therefore, b is equal to here the 4, get it in the left hand side, minus 4 plus 1 is a minus 3. So b is equal to minus 3. Okay, my dear students. I can substitute e 2 j omega plus 1 by j omega plus 2 whole square is equal to a as 2 by j omega plus 2 and b is minus 3 j omega plus 2. Okay. That is equal to x of omega is equal to a, we got 2 j omega, 2 by j omega plus 2 and plus, and b we got as a minus 3. Minus 3 j omega plus 2 whole square. Okay, my dear students. So even if after the apply the LCM with the j omega plus 2 whole square, 2 into j omega plus 2 and minus 3, solve that j omega is a 2 j omega into 2, 4 minus 1, minus 3 is a 1. So it satisfies the a and b values also. Now I can apply the inverse Fourier transformation on both sides. Inverse Fourier transformation. inverse Fourier transformation on both sides. Apply. See, what is the inverse Fourier transformation of x of omega? X of omega is equal to x of t. That is equal to inverse Fourier transformation of 2 by j omega plus 2. Okay. Here the j omega plus 2. Plus inverse Fourier transformation of minus 3 j omega plus 2 whole square. Okay. We already know the Fourier transformation of e power minus at mu of t. E power minus at mu of t. What is the Fourier transformation, my dear students? Is 1 by a plus j omega and t into e power minus at mu of t. What is the Fourier transformation? Fourier transformation is 1 by a plus j omega whole square. Okay, my dear students. See, by using this Fourier transformations of the time domain signals in the frequency domain signals, but here the frequency domain signals you have to convert into the time domain. See, the 2 is a constant. So Fourier transformation of x of omega is equal to x of t. Okay, x of t is equal to. So here the 2 is a constant. Write the 2 here. 2. Now observe 1 by j omega plus 2. The same thing here. 1 by j omega. Instead of a, here the 2 is there. So e power minus at mu of t means what is the Fourier transformation? 1 by a plus j omega. So inverse Fourier transformation of 1 by a plus j omega is e power minus at mu of t. But instead of a, here the 2 is there. Okay. So we write it as inverse Fourier transformation is e power minus 2t mu of t. Understand, my dear friends? For the first inverse Fourier transformation, the 2 is a constant. You can write this outside. Now the inverse Fourier transformation of 1 by j omega plus 2 is, instead of a, here there is a 2. So write as e power minus 2t mu of t. And coming to the second term, plus, here the minus 3 is a constant. Minus 3. Now 1 by a plus j omega whole square. See the 1 by a plus j omega whole square. What is the a here? The 2. But it is a t into e power minus 18 mu of t. It is a function as minus 3 into t e power minus 2t mu of t. Okay, my dear friends. For the given x of omega, 2j omega plus 1 by j omega plus 2 whole square. What is the inverse Fourier transformation? X of t is equal to 2 into e power minus 2t mu of t minus 3t into e power minus 2t mu of t. Okay. Finally, the expression, it is a small letter, my dear students. X of t is equal to, what is the common term of the two terms? 2 minus 3t whole multiplied with e power minus 2t mu of t is the inverse Fourier transformation of the given function x of omega is equal to 2j omega plus 1 by j omega plus 2 whole square, 2 minus 3t e power minus 2t mu of t. In these two terms, e power minus 2t mu of t is a common. So 2 minus 3t. Following my dear students. Now see here. What is the final answer? We got 2 into e power minus 2t mu of t is here. 2 into e power minus 2t mu of t minus 3 into 3t e power minus 2t mu of t. They are also saying the same thing. A by j omega plus 2 plus b by j omega plus 2 whole square. And the equation becomes that 2j omega plus 1 is equal to a into j omega plus 2 plus b. We got the a is equal to 2 and the b is equal to minus 3. Substitute a as 2 by 2 j omega plus 1 plus j omega plus 2 minus 3 by j omega plus 2 whole square. And inverse Fourier transformation is 2 into e power minus 2t mu of t minus 3 into t e power minus 2t mu of t. Okay, my dear students. So now I completed the first one. Inverse Fourier transformation of x of omega is equal by using the partial fraction expansion method, my dear students. Now the second one, they're asking that is x of omega is equal to 1 by a plus j omega whole square by convolution property. By convolution property. So before going to convolve by using the convolution property, you can solve this 1 by a plus j omega whole square is directly by using the partial fraction expansion also. How? You see the x of omega is equal to given 1 by a plus j omega whole square. We already know this is a t into e power minus at mu of t. By using the partial fraction expansion method, a by a plus j omega plus b by a plus j omega whole square. Okay, my dear friends. So take the LCM here. A plus j omega whole square and a into a plus j omega plus b. Same thing. What is here in the left hand side? 1 a into a plus j omega plus b. Okay. Now substitute the j omega is equal to minus a, j omega is equal to minus a, b is equal to 1. Okay. J omega is equal to minus a. Here the 1 is there, and b is equal to 1. And the constant values you can observe a into a plus b. B is a 1. So 1 get cancelled. A is a 0. 1 minus 1. A is equal to 0, my dear students. A is equal to 0. B is equal to 1. Again, we'll get the same thing. 1 by a plus j omega whole square on. So we are not going for the partial fraction method because directly they given it is a 1 by a plus j omega. After using the partial fraction method also, the finally we are getting the 1 by a plus j omega whole square. So for this expression, we go for the by using the convolution property to find the inverse Fourier transformation of the x of omega. Okay, my dear students. Now let us see that inverse Fourier transformation by using the convolution property. What is the convolution property? Saying that x of or the y of t, let us take y of t is equal to x of t with the convolution of h of t. Okay, my dear students. What is the inverse Fourier convolution method? Integral minus infinite to infinite x of tau h of t minus tau d tau. is a convolution of the two signals, x and the h. Okay, x and the h. But here they are asking that is x of t is equal to x of omega means you have to find out the x of t. X of t. Okay. I will solve in the whiteboard. Take the next one. Find inverse Fourier transformation x of omega is equal to 1 by a plus j omega whole square using convolution property. Okay, my dear students. Now see, the x of omega is equal to 1 by a plus j omega whole square. I'm using this 1 by a plus j omega as a one function. Another one is 1 by a plus j omega. As this considered as a x1 of omega. Another one is a x2 of omega. As x of omega is equal to. Okay, my dear students. So by using the convolution property, what is the convolution property? Saying that x1 of t is a time domain function. Convolute x2 of t is a Fourier transformation x1 of omega into x2 of omega. So time domain is a convolution means frequency domain is a product. Okay. So now I am taking the x1 of omega. x1 of omega is equal to, you got the 1 by a plus j omega. 1 by a plus j omega. Okay. Now I am finding out the inverse Fourier transformation of the x1 of omega only, my dear students. So inverse Fourier transformation of x1 of omega is, what is the 1 by a plus j omega is x1 of t is equal to e power minus at mu of t. Okay. I'm finding only the x1 of omega, not the x of omega here, what they given. Similarly, for x2 of omega also, what is the x2 of omega? The same thing, 1 by a plus j omega. What is the inverse Fourier transformation of x2 of omega? x2 of omega is the same thing. For this frequency domain function converted to the time domain function, x2 of t is equal to e power minus at mu of t. Both we got e power minus at mu of t. But we need the x of omega with the multiplication factor of x1 and the x2. Using the convolution property, how to find out the inverse Fourier transformation of x of omega. Okay, what is a convolution? Now I am taking x of t is equal to x1 of t convolution with x2 of t. Okay, I need the x of t because the given x of omega frequency, and we have to find out the time domain function. What is the formula for the x of t is equal to integral minus infinite to infinite x1 of tau, here it is a tau, x2 of t minus tau d tau. Okay. Now I am substituting x1 of tau here. Integral minus infinite to infinite. What is the x1 of t? We know the t is a variable. Change as a t as a tau. x1 of not the x1, sorry. E power minus a. Here the tau is there. Now I am replacing the t as a tau. E power a tau mu of tau. Okay. Is x1 of tau. And x2 of t minus tau. What is the x2 here? E power minus at mu of t. Instead of t here, the t minus tau. Replace the t as minus a, t minus tau, and mu of t minus tau d tau. Following, my dear students? So I replace here the tau, t as a tau for x1, and x2 t as a t minus tau. Okay. Minus a into tau. So x2 of t minus tau. So what is the mu of tau? Mu of tau is equal to 1 for tau is greater than or equal to 0. The remaining functions is the remaining function, nothing but the tau is less than the 0 is as 0 values. Similarly, what is the t minus tau here? Mu of t minus tau is equal to 1. The tau is greater than or equal to 0. What is it here? T minus tau is greater than or equal to 0. Okay, my dear students. Don't confuse here. Mu of tau is equal to 1 for the tau is greater than or equal to 0. Whatever the factor is there in the parenthesis, that is greater than or equal to 0 here. And similarly, in this also, what is the factor here? The t minus tau is there. The t minus tau is greater than or equal to 0. Now, the t is greater than or equal to tau here. I brought that it is a minus tau to right hand side. And tau is, what is the tau? Tau is less than or equal to t. So t is greater than or equal to tau means what is the tau is? Tau is less than or equal to t. Now we have the two ranges are there for the tau. For keeping of mu of t as a 1 and mu of t minus tau is also the 1. There is a tau is greater than or equal to 0 is there. And the tau is less than or equal to t. So using these two, the combine the range is 0 less than or equal to tau less than or equal to t. Is a combined range of the tau by taking off tau is greater than or equal to 0 and the tau is less than or equal to t. See here the tau is less than or equal to t and 0 less than or equal to tau means tau is greater than or equal to tau. So now replacing of mu of tau is 1, mu of t minus tau is equal to 1 by changing the limitations here. So carefully you can listen, my dear students. So changing the limitations minus infinite to infinite as 0 to t. Why we are changing these limitations? Because here we are applying with respect to the tau. Okay, 0 to t as change of minus infinite to infinite by keeping mu of tau is equal to 1 and the mu of t minus tau is equal to 1, my dear students. Okay. Now, go in the next page. Implies x of t is equal to integral. Now I'm changing this 0 to t. 0 to t e power minus a tau and mu of tau is equal to 1 and e power minus a t minus tau, and the value is also the 1 and d tau. 0 to t. Following, my students. So now the integral 0 to t e power minus a tau and e power minus a t and e power plus a tau. And now it is 1 the e power minus a t and the theta. Here with respect to the tau is there, with respect to the tau. But e power minus a t is a constant, e power minus a t constant. But there is a changes is there, the e power minus a the tau and the e power plus a the tau is a zeros. Okay, my dear students, 0. So what you have to do here is see. So what we explain here, whatever the same thing, e power minus a t mu of t, e power minus a t minus tau. Observe here, mu of tau is equal to 1. Mu of tau is equal to 1. The tau is less than the 0, and mu of t minus tau, mu of t minus tau is equal to 1, and the t less than or equal to tau. So finally, we remaining here, it is the integral 0 to t only. Integral 0 to t e power minus a t dt. Not the dt, my dear students, it's the d tau. Okay, e power minus a t d tau. So these limitations is only for the d tau only. Now, you can apply here e power minus a t is a constant. Integral 0 to t e power minus a t plus e power minus a t is a becomes of e power 0 into e power minus a t is a d tau only, my dear students. A t into d tau. What is the e power 0 is a 1. So integral 0 to t e power minus a t d tau, that is equal to e power minus a t is a constant, take it as a outside, and integral 0 to t 1 into d tau. What is the with respect to the constant integral value is a t only, tau, not the t, e power minus a t tau, because we are applying with respect to the tau. The upper limit is a t, lower limit is a 0. Therefore, x of t is equal to e power minus a t, upper limit is a t, lower limit is a 0. So x of t is equal to t into e power minus a t. And you can multiply that as a mu of t also. What they ask here? Find the inverse Fourier transformation of x of omega 1 by a plus j omega whole square. We already know the 1 by a plus j omega is e power minus at mu of t, and 1 by a plus j omega whole square means is multiplied with the t into e power minus at mu of t. We're find out only the from 0 to infinite on the positive values. For inverse Fourier transformation of x of omega is equal to 1 by a plus j omega whole square is t into e power minus at mu of t. Understand, my dear students? Same thing, they also explained e power minus 0 to t e power minus at d tau, and 1 the d tau is a t after substituting the upper limit and the lower limit, t into e power minus at mu of t. Okay. Here we are using convolution property. What the convolution property saying that x1 of t with the convolution of x2 of t, what is the Fourier transformation? x1 of omega and x2 of omega. So these are the two multiplication factors. Before that, the given function you can write as a two functions. One is x1 of omega and x2 of omega. Here itself you can find the inverse Fourier transformation of x1 of t and x2 of t, and then by using this x1 and x2, substitute in the convolution formula and simplify that to get the inverse Fourier transformation of the given function. Okay, we completed the second one also, my dear students. One is by using the partial fraction expansion method, and another way you can find by using the convolution property also. You see the third example here. Find the x of omega is equal to e power minus magnitude of omega. E power minus magnitude of omega. You already know, my dear students. E power minus at. E power minus at. It's a double-sided. So x of t is equal to e power minus a the magnitude of t. What is the x of omega? We got x of omega is equal to e power minus a magnitude of t. What we got, the students, is I will show that the previous slides. This is the okay, I will find that. So whatever this here, the 2 by j omega we got for the signum function. Show this is okay. E power minus at, and t is equal to 0. And t is equal to 0. Not the t is equal to 0. T is greater than the 0. For t is greater than the 0 means t is a positive. At the time the x of t is e power minus at. E power minus at. And t is less than the 0, it becomes of e power plus minus, it is a minus value e power plus at. So inverse Fourier transformation becomes integral minus infinite to 0 minus e power at into dt plus integral 0 plus to infinite e power minus at dt. So two functions will get because it is a magnitude. For above values, the t is a positive, then it becomes of e power minus at. For below values, the t is minus values. So minus of minus is becomes of the plus. What is the e power at? E power at by the a as a 0 minus infinite as 0 minus or the 0 plus is both are the same, and e power minus at by minus a with the infinite and the 0 plus. So 1 by a into 0. When I am substituting the 0 here, the 1 by e power 0 minus e power minus infinite plus e power infinite minus e power 0 by minus e. Okay, my dear students. So 1 by a into 1 plus, why it is a plus 1 plus 1, it here, 1 by a. So 2 by a. Plus here the omega t is also there. It becomes of j omega. 2 by a j omega. So actually. So e power minus omega is given. What is the a here? A is a value is a 1. A is a 1. You can use this as an inverse Fourier transformation by using this function. Or another one is that x of omega is equal to e power minus 2 omega into mu of omega. E power minus 2 omega into mu of omega. Let's take it as e power minus 2 omega as apply the inverse Fourier transformation by using the direct formula method is there. E power minus omega, and here also the e power minus omega, the x of t is equal to integral minus infinite to infinite 1 by 2 pi we have, and e power minus 2 omega mu of omega into e power plus j omega t d omega. So omega, mu of omega is from 0 to infinite, e power minus 2 omega into e power plus j omega. Okay, bases are the same. You can add powers here and apply the integral from 0 to infinite. So now you can see that also 1 by 2 omega integral 0 to infinite, because I keep substituting the mu of omega is equal to 1. So e power minus, here the omega you can take as a common. Omega is you take as a common because with respect to omega we are applying, and minus is already there, 2 minus jt, 2 minus jt. So e power minus 2 omega and e power plus j omega t d omega. So 1 by 2 omega, 2 pi, not the 2 omega, sorry, and e power 2 minus j into t omega by 2 minus j into t. By substituting the upper limit is infinite and lower limit is 0. Upper limit you can substitute e power infinite is 1, 0, and lower limit you can substitute e power 0 is 1. Finally, we get x of t is equal to Here the 1 by 2 pi minus of 2 minus j into t is the inverse Fourier transformation of the given fourth one. Okay, my dear students. Why we got the minus here? By substituting the lower limit, there is a minus term is there, minus 1 by 2 pi 2 minus j into t. The inverse Fourier transformation. Okay. So coming to the next one. Find the Fourier transformation of the function x of t minus t naught is equal to e power minus t naught into mu of t minus t naught. We already know the e power minus at mu of t. E power minus at mu of t is the a value is a 1, my dear students. A value is a 1 by a 1 plus j omega 1. How we got the e power minus j omega t naught? Because it is not the mu of t, it is a shifted version. According to the time shift property, x of t minus t naught is there. What is the time shift property saying that x of t minus t naught? What is the Fourier transformation is? Fourier transformation is e power minus j omega into t naught x of omega. Okay. What is the x of t? Fourier transformation is x of omega. But here it is given as a e power minus t naught. E power t minus t naught into mu of t minus t naught. So what is the e power t? E power minus j omega into t naught and whole divided by the e power minus at. E power minus at the mu of t. What is the Fourier transformation? Fourier transformation is 1 by a plus j omega. What is the a here? 1. So e power minus t mu of t. Fourier transformation is 1 by 1 plus j omega. When it is shifted, the t functions e power minus of t minus t naught and mu of t minus t naught using the time shift property, saying that for this x of omega, there is a multiplication factor of e power minus j omega. Okay, my dear students. So the Fourier transformation is already we have the 1 by 1 plus j omega and can multiply with respect to e power minus j omega t naught. So e power minus t naught mu of t minus t naught is a Fourier transformation is 1 by 1 plus j omega e power minus j omega t naught using the time shift property. Okay, my dear students. It's the first example. Find the Fourier transformation of the function x of t minus t naught is equal to. Is the given signal is shifted with the t naught samples. The output is the e power minus exponential value is also shifted with the t naught samples, and step function is also shifted with the t naught samples. And only can multiply this e power minus j omega t naught, my dear students. Okay. That another example is given. These are some examples measured in the Fourier transformation of examples. X of t is equal to mu of t plus 1 minus mu of t minus 1 cos 2 pi into t. Cos 2 pi into t. We know the cos function in terms of the exponential values. Fourier transformation of cos 2 pi into t. It is a Fourier transformation of e power j 2 pi into t plus e power minus j 2 pi into t whole divided by 2. So Fourier transformation of 1, we know the 2 pi delta omega. Fourier transformation of e power j 2 j omega naught into t There's a 1 into only here. So 2 pi into delta omega as omega minus omega naught. So cos 2 pi into t as pi delta of omega minus 2 pi, because here the 2 pi is there instead of omega naught, plus pi into delta, here the minus is there, becomes is a plus instead of omega, here the 2 pi. So pi delta omega minus 2 pi, pi delta omega plus 2 pi for cos function. And they're asking that x of t is equal to mu of t plus 1 minus mu of t minus 1 into cos 2 pi. Into cos 2 pi. So the Fourier transformation of mu of t plus 1 minus mu of t minus 1 is mu of t plus 1 is varies from the minus 1 into 1. Why the range is minus 1 to 1 means mu of t is equal to 1 for t is greater than or equal to 0. Okay, my dear students. But here mu of t plus 1 is equal to 1 for t plus 1 is greater than or equal to 0. Okay. And t is greater than or equal to minus 1. Following, my dear students? And for this function, the mu of t minus 1 is equal to 1 means the t minus 1 is greater than or equal to 0. And t is greater than or equal to 1. So minus 1 less than or equal to t greater than or equal to 1. So see here, t is greater than or equal to minus 1 and the t is greater than or equal to 1. So it is varies in between of minus 1 to 1. Varies between minus 1 to 1 and its Fourier transformation is e power minus j omega t into dt. Okay. That is equal to e power minus j omega into dt is the minus 1 by j omega, and you can substitute upper limit is e power minus j omega into t as a 1 minus j omega, and lower limit you can substitute the minus 1, you get the plus here. So e power minus j omega minus e power plus j omega is can multiply with this sign minus as e power j omega minus e power minus j omega by 2j. There is no 2 here. Now can multiply the 2 in the numerator and the denominator. It becomes of sine. So 2 sine omega by omega. Here the omega is there. The Fourier transformation of x of t is the Fourier transformation of mu of t plus 1 minus mu of t minus 1 cos 2 pi into t. So individually we find it is Fourier transformation of this one and Fourier transformation of this one. Using multiplication method or multiplication property or the modulation theorem or modulation property, what they are saying, the time domain functions is multiplied. Time domain functions is multiplied. What is the Fourier transformation? Convolution. We got x1 of omega means this one. X1 of omega as 2 sine omega by omega, and y1 of omega is pi delta omega minus 2 omega pi delta omega plus 2 omega. So using this x of tau, y of omega minus tau d tau. X of tau. X of tau means change the omega as tau here. 2 sine tau by tau. And y of omega minus tau. So wherever it is a omega is there, substitute that omega as omega minus tau. So pi delta into omega minus tau. Already we have the minus 2 pi. And in the second term, pi delta into pi into delta. So you take the common here the pi is there, my students, actually. pi delta omega. Omega is now omega minus tau plus 2 pi. Okay. Here the pi delta means here also the pi delta. There is something wrong is there. Now write it is a pi delta into d term. So the x of omega is equal to minus infinite to infinite 2 sine tau by tau, and here the pi is there for the first term. Pi and pi get cancelled, and the 2 is also there in the first term. So 2 is also cancelled. So for the first term we got the sine tau by tau delta omega minus 2 pi minus tau. And the second term we have pi is there, pi get cancelled and pi get cancelled here, and we get the sine is multiplied for the two functions. So sine is a multiplied here, the one of the bracket is also there. Sine pi tau by tau, and already the 2 is there, and here the pi, the 2 pi and the 2 pi get cancelled. Pi delta omega plus 2 pi minus tau d tau. Now you got the two integrations. We know one of the properties there, the integral minus infinite to infinite x of t delta of t minus t naught dt is equal to x of t naught. I already explained in the properties. Any signal we can take, any signal x of t, it is multiplied with delta of shifted function or delta t. Suppose integral minus infinite to infinite x of t with the delta of t dt. It is always equal to x of t only, because the delta function is only one value t is equal to 0. Suppose integral minus infinite to infinite x of t. Now this delta is shifted, whatever the value, let us take it is a t naught. But we got x of t naught. Suppose it is a t2, so it is x of t2. So using this property, saying here the same thing. What is x of t sine pi, or the pi, sorry, sine tau by tau. So sine tau by tau, and delta function is there. That delta is t, means is x of t, that is a tau function. The tau is there here, the t tau minus these functions. Tau minus this function, my dear students. Tau minus means the x is function with the omega minus 2 pi. So sine omega minus 2 pi by omega is omega minus 2 pi. Any confusion here? Just see what they are saying here. So integral minus infinite to infinite. What I told now itself, x of t delta of t minus t naught is equal to, with respect to the dt also there, is equal to x of t naught, my dear students. X of t naught. Okay. Now, here x of t, what is x of t? Is a sine tau by tau. Sine tau by tau. But what is a tau here? Sine t term is a tau, because with respect to the tau. Okay. Sine tau by tau. Delta is there here. Delta tau. And take the minus of omega minus 2 pi. Why I am taking the delta of, take the minus as a common, tau. Minus omega plus 2 pi. Even you can write like this also. The delta is an even function, we'll get the same thing. delta is an even function, we'll get the same thing. Nothing is a difference. So delta of tau minus of omega minus 2 pi. Okay, my dear students. I'm taking here the minus is the common. Omega minus 2 pi. Now it is in the form of t minus t naught. What is the shifted samples here? Omega minus 2 pi. Now the replace of sine tau by tau is sine of, instead of tau it becomes of omega minus 2 pi whole divided by omega minus 2 pi. It's only right here. For the second term, we can observe here the second term, delta is, take the common of minus tau, or the minus tau minus omega minus 2 pi. Okay. Since it is an even function, it becomes of tau minus of omega plus 2 pi. Okay, my dear students. So the delta is shifted with the samples of omega plus 2 pi. It is multiplied with the x of t, not the multiplied. The signal will get at the t naught, x of t naught. So what is the x here? Sine pi by x of t is sine tau by tau. Again, you can write the plus sine omega plus 2 pi whole divided by omega plus 2 pi. Got it, my dear students? This is another method to find the Fourier transformation. For the given mu of t plus 1 minus mu of t minus 1 by into, not the by, cos 2 pi into t by using multiplication property. What is a multiplication property saying? X of t with the y of t, the time domain is a multiple product. Frequency domain is convolution in the Fourier transformation with the multiplication factor of 1 by 2 pi. So individually you can find the Fourier transformation of this one and Fourier transformation of cos 2 pi. Then using this property, you can find out the x of omega is equal to sine omega minus 2 pi by omega minus 2 pi and sine omega plus 2 pi by omega plus 2 pi. Got it, my dear students? So the way you can find out the inverse Fourier transformation and the Fourier transformation using the properties. Inverse Fourier transformation with the using convolution property, and here the Fourier transformation using the multiplication property, or the inverse Fourier transformation you can also find by using the partial fraction expansion method also. You can see the other examples of the Fourier transformation graphical representation in the next class. So only one example is there. So with this 2 or 3 inverse Fourier transformation also we have. After that, so by tomorrow we can conclude the Fourier transformation and inverse Fourier transformation, and also you have to conclude the unit 2 also. By Tuesday you have to complete, we can complete the Fourier transformation, the second part of the second unit. Okay, my dear students, if you have any doubts, please rise. Thank you.